In section 6.2, we're going to talk about measures of central tendency and dispersion. So if you read the gray box in the middle of the page on page 379, it says, you can use different measures to interpret and compare sets of data. One way to summarize a set of data is to use a measure of central tendency. Mean, median, and mode are all measures of central tendency. It's just a fancy way of saying mean, median, and mode. This is the most important part. The measure of central tendency that best describes a data set may depend on whether the data set has an outlier. An outlier is a data value that is much greater than or less than the other values in the set. Below is a table showing mean, median, and mode, and when to use each measure of central tendency in comparison to the outlier. So I'm not going to read mean, median, mode for you. You've done that since elementary school. But I do want you to use when to use it, because it will depend on whether or not your set of data has an outlier. The first set of problems we're doing are finding measures of central tendency. So on page 380, if you look at problem 1, you have the 6 values listed of weight of books and ounces. So we have to find the mean, the median, and the mode. Now I'm not going to go on these in detail because you've done these. The mean, you'd add them up, divide by how many numbers are there, which would be 6. You get a mean of 12. The median is the middle number put in order. If you put these in order, you'd have 9, 10, 10, 12, 15, and 16. 10 and 12 would be your two middle numbers, so you have to find the average of 10 and 12, which would be 22 divided by 2, which gives you 11. The mode in this set of data is 10 because it occurs the most. Now, do you have an outlier? Is there a number that's that's greater than or less than this group of numbers? No. So you could say the mean would be the best set of data to probably describe this set of data. So mean would be the best way. But if you look at number 2, just look at it. You don't have to solve it. But number 2, is there an outlier? Is there a number that's either higher or lower by a greater amount than the rest? Yeah, we have 134. So if you look at your chart, the chart actually says that, well, we wouldn't use the mean because the mean we want to use when it does not have an outlier, and it does. But the median says that when it does have an outlier. So it would most likely be the median for number 2. In problem number 2, we're going to be finding a data value. And you can use an equation to find a value needed to achieve a given average. So for example, let's start with problem 3. Problem 3 says, find the value of x such that the data set 31.7, 42.8, 26.4, and x has a mean of 35. Well, what do we know? The mean is adding them all up, dividing by how many numbers are there, and giving us a mean. So we know the mean is equal to 35. How many values do you have? You have 4 of them. You have the x plus the other 3 values. And if you add up the other 3 values, 31.7 plus 42.8 plus 26.4, that gives you 109 tenths or 100.9. And you divide all those by 4 because there are 4 numbers, equals 35. All you do now, solve the equation. Times both sides by 4, you get x plus 100.9. Please don't times the top by 4 because we're getting rid of the divide by 4. So you do not need to multiply the top by 4. So we take 35 times 4. That's going to give us 140. And then we subtract 109 tenths. So 140 minus 100.9 gives me the value 39.1. So the fourth value that would make a mean of 35 would be 39.1. If you look at example 4, example 4 says, the line plot at the right shows the numbers of weekly sales a salesperson made in the first 9 weeks of a 10-week sales period. The salesperson's target is an average of 14 sales each week. How many sales does the salesperson need in the 10th week to meet the target average? Well, we know there's 9 scores, and our 10th score is x. So we would write x is the 10th score, plus all of the other scores. So we have to add them all up. So we would add 12 plus 13 times 2 plus 14. There's 3 of those. plus 15 times 3, and that gives you 125. Divided by, well, there's going to be a 10-week period, so there's going to be 10 sales scores, and that's going to give us an average or a mean of 14 sales. So, times 10, we're going to get x plus 125 equals 140. We subtract 125, and you're going to get 15 sales as your 10th week. Problem 3 is on finding the range. Now, if you look at the top, it says a measure, we're on page 382, a measure of dispersion describes how dispersed or spread out the values in a data set are. One measure of dispersion is called the range. The range of a set of data is the difference between the largest and smallest values, the greatest and least data values. So if we look at the got it problem, the got it problem says, for the same days, the closing prices in dollars of stock C were 7, 4, 3, 6, and 1. The closing prices in dollars of stock D were 24, 15, 2, 10, and 5. What are the range and mean of each set of data? Use your results to compare stock C and stock D. Now, looking at page 382 at the bottom, it says that a line plot is a data display in which each mark above a number line corresponds to each data value. Line plots are sometimes called dot plots when the mark used to represent each data value is a dot. So if we look at the got it problem at the top of page 383, it says the list below shows the number of students in each homeroom at Jefferson High School. And you are given a whole bunch of numbers, and each of those numbers represents the number of students in a homeroom. Make a line plot. So part A, if you make a line plot, what does this represent? So we have to write a title. It represents the number of students. And you could say at Jefferson High School if you wanted to. And then at the bottom, all line plot is just a line, and we put numbers at the bottom. So we look, and we're not going to use intervals. We look to see what our lowest value is, which is 19. And our highest value is, looks like 24. So we just count up the 24. So 19, 20, 21, 22, 23, 24. And that would be the number of students. So all we do now is you can just go from each number and then put an X for each one. So for example, if you wanted to, you could say, well, 21 is the first number, I'm going to put an X here. 22 is the second number, I'm going to put an X here. 19 is the next number, I put an X here. 20 is the next number, I put an X here. You could do that, or you could just count up all the 19s, all the 20s, and all the 21s, and so on. So I'm going to go ahead and finish this graph for you. So there are 4 homerooms that have 19 students, 5 homerooms that have 20 students, 6 that have 21, 2 that have 22, 2 that have 23, and 1 that has 24. Part B says, find the mean, median, and range of this data. So the mean, add them all up, divide by how many scores are there, and it looks like there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 2 is 20. So there are 20 scores. If you added all 20 scores up, divided by 20, you would get a mean of 20 and 8/10. The median. The median is the middle number. Now here's a little trick. You don't have to put them all in order. If there are 20 numbers, that means the 10th and 11th number would be your middle scores. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know the two middle numbers are both 21. Well, if you found the average of 21 and 21, it'd just be 21. So your median is 21. Your mode is the number that occurs the most. Well, there are 6 classrooms of 21. That's the highest. So your mode is 21. And then the range would be the highest number, 24, subtracted by 19, the lowest number, and 24 minus 19 would give us a range of 5. C asks, how can you use the line plot to determine whether the mean and median are equal? Well, you can use the line plot to see whether the data are symmetrical. If they are, then the mean and median are equal. If they are not, the mean and median are not equal. What that means is this. If this right here, if this was symmetrical, like the same number of x's over here, the same number of x's over here, well, then the mean and median would have to be equal because you have the middle number, and the middle number is in the middle, which is also the average. So they would be equal. But if they are not, like they are here, the mean and the median are not equal. And if you notice, the mean is a little smaller because there are more numbers that are less than the median, which is 21. In problem 5, we're going to be comparing measures of central tendency. So we're going to compare the mean, median, and mode. So let's look at number 9. In number 9, on page 385, it says, determine which data set has a greater mean and a greater median. So we actually, obviously, if you wanted to on number 9, you could figure out what the mean and median were on each of them and then compare it. But you can actually look at it just based on the graphs. So in number 9, we have Company A and Company B. Company A and Company B are talking about monthly earnings in the thousands of dollars. So we're going to start by comparing the mean. If you look at number 9 on Company A, you have more numbers towards the lower end, 51 and 52. But in Company B, you have more numbers, more monthly earnings that are higher, 52, 53, 54. So which one, if you took the average of all of them, which one would be the higher mean? Well, you could say Company B has a higher mean, and if I asked you why, you would say because it has more earnings that are a bigger number than Company A. Now, if you look at the median, the middle number, which one, if you would split them right down the middle, where do you think the middle number is going to be? Is it going to be smaller or bigger in which company? Well, in Company A, if you found the middle number, it'd likely be around maybe 52-ish, 50, maybe 53, maybe between there. But Company B, you have more numbers towards the end. So it may be like 53. So Company B also has a higher mean and median. So the median is higher as well as the mean.